Hello, Woodland Christian Chemistry. Let's start off Chapter 11, Section 2 with our mole map. So take a look at the mole map. I have increased what we are learning on our mole map because we're now in Chapter 11. Chapter 10, remember, was just about this left side of the mole map. We only had one compound or molecule that we were working with, and so we only used the left side of our mole map. We took grams. What are we given? Grams. And we were asked to convert to particles. Remember, we were talking about how you can't go directly from grams to particles. You have to go into moleville, use your periodic table, find the molar mass, or tally the molar mass for a compound. And then from moles, you could use Avogadro's number to calculate the number of particles. So that was all Chapter 10. But now we're in Chapter 11, and as you learned in Section 1, we're going to be using a mole ratio to translate from one compound to another compound. I'm going to call these particles because particles is a broad term that can mean molecule or element or a formula unit if it's ionically bonded. So particle is the term that I'm going to use on the mole map here. So the way these problems are going to work is if you're given grams in the problem, use your periodic table to find the molar mass for 1 mole of that particle. And then you're going to be asked to translate to another part of the chemical equation. So I'm just going to call that B. We're in moleville. We need to use moles of A on the top, moles of A on the bottom, and use our molar ratio taken and those numbers taken from the chemical equation that is balanced. Very important detail there. And moles on the top, you're going to put 1 mole on the bottom, and what you're going to put on the top of that fraction is either 6.02 times 10 to the 23 if you're asked for particles of B, or use your periodic table to find the molar mass to find grams as your final answer. So notice that this mole map has like many different directions you can take with it. Grams to moles to particles if we're just dealing with a single particle, or grams to moles using mole ratio to particles even. So we might even go this route and end up with something different than what we started with. Going this route, you could go from grams to grams, except going from grams to grams here is going to let you start with a certain number of grams of A to get to a certain number of grams of B that you need to make this happen. Now, I want to point out just that you don't have to have A and B on opposite sides of a chemical equation. A and B could theoretically both be reactants, or they could both be products. Or A could be a reactant and B could be a product. So these don't have to be on opposite sides of the reaction arrow. They could be on the same side. So let's say we're given a certain amount of A and we're trying to figure out how much of B we need exactly to make the reaction happen. These could both be reactants. So enough of me talking. Let's try out some problems and see how this works out using our mole map as a guide. If it's your second time watching this video, go ahead and pause at this point. Make sure you have this mole map copied down. This is a part of your notes, and you're going to want to refer back to it as you're working out these problems throughout the rest of the chapter. So copy that down, push pause, and then copy this down as well if it's your second time through the video, pushing pause now to try this out. So Section 2 is all about stoichiometric calculations. Example number 1 says how many moles of table salt are produced from 0.02 moles of chlorine. Notice that chlorine is Hankelbrieft, so we'll have to remember Hankelbrieft, but don't sneeze on anyone. And chlorine is a part of Hankelbrieft, so that's a diatomic ion. Push pause, try to work out the chemical equation first of this, and then we'll do the calculation together. So check out your answer and compare to my chemical equation. It says that moles of table salt are produced, so that's going to be a product, from moles of chlorine. So chlorine, Hankelbrieft, of course, is going to be a reactant. And then notice that Na is missing from the left, so make sure you include it. Na as a solid. Na sodium is not Hankelbrieft, so that's just automatically assume it's just a single atom of sodium here. When you balance, make sure there's 2 chlorines here, so put your 2 here. That makes 2 NAs, so put a 2 here. Remember when you're balancing to not mess with the subscripts, only work with your coefficients to make sure that's balanced. So our problem gives us, you say self, what are you given? Oh, I'm given this number of 0.02 moles of chlorine. So that's where we'll start this problem off. 0.02 moles of chlorine. Moles of chlorine on the top, moles of chlorine on the bottom. And notice I didn't put a number there at first. I like to think about my numbers later. We have moles of chlorine. And so we're right here as we start out this problem. Where I want to go next is my mole ratio. So I'll take a look at my balanced chemical equation. For chlorine, I have a 1 coefficient implied, so I will use the number 1. And where I'm trying to get to is how many moles of table salt. So I'll put table salt on the top. And how many moles of table salt? I'll look at my balanced equation. Table salt has a 2, so I'll use my molar ratio to work out this problem. Moles of table salt on the top. Oh wait, I'm already at moles of table salt, which is what I'm trying to get to. So I can just go ahead and use my white out there. I am done this problem because I have arrived at moles of table salt. So go ahead and throw this into your calculator. In effect, for this problem, we are doubling our moles. So actually, I can do this one in my head. That's going to be a double 0.02, which is 0.04 moles of table salt. Now, I love in this problem, stoichiometry is kind of fun for me because I just love like these slashy moves right here where I can think about the fact that the units have canceled and therefore I have sodium chloride as my answer there. So I'm going to put up another problem for us to work on. So I want to point out in that last problem that we started with moles of A, used a mole ratio, and ended up with moles of B. In this next problem, we're going to be given grams of A, and we're going to be asked to find grams of B. So we're going to go through moles, mole ratio to cross this border of moleville, use a 1 to find grams from our periodic table to end up with grams as our final answer. So if this is your second time watching this video, go ahead and pause. We're going to look at photosynthesis and go ahead and copy this down, and it's not balanced, so go ahead and balance it first. So I hope you got a chance to try that on your own first. I see 6 carbons, so I'll put a 6 over here to balance out my carbons on the left. Let's see, what else can I do? There's 2 O's on the right, so probably as a strategy, I'm going to do my H's first. Well, there's also 2 O's on the left, so that's kind of complicated. Only 12 H's on the right, so I'll put a 6 here in front of water to make 12 H's as well on the left. Go ahead and tally up those O's. I think that we find that the O's are almost balanced, except we're missing some O's over here. So 12 plus 6 is 18. There's already 6 here. I think I can add a 6 in front of the O2 to make 12 more. So 12 plus 6 is 18 on the right as well. So our O's are now balanced. So let me put up the question stem for this one. So try this one out. It says 24 grams of carbon dioxide reacts with excess water. So the excess water basically tells you to not worry about how much water is lying around. We're just going to assume that there's enough water. It's kind of like when you try to go bake some cookies and you realize you have plenty of flour. You got like this whole case of flour, but you are limited on your chocolate chips. Those chocolate chips, we're running out of chocolate chips in the bag, so that would be limited. But we're going to assume in this problem that water is in excess. We have plenty of water to go around, so what is limited in this problem is our 24 grams of carbon dioxide. So that's the number you're given. Put 24 grams of carbon dioxide on the top, grams of carbon dioxide on the top, grams of carbon dioxide on the bottom. Good job. Pause the video, try this out. And here's the answer. 24 grams of carbon dioxide on top, grams of carbon dioxide on the bottom. We go to moles because we need to go through Moleville to figure out grams of glucose. 1 mole weighs that much from our periodic table tallied up. Moles of carbon dioxide on the top, moles of carbon dioxide on the bottom. This is the point at which we're crossing the border to find moles of glucose. 6-to-1 ratio that came from our chemical equation here, 6-to-1 ratio. There's a 1 implied there. Moles of glucose on the top, moles of glucose on the bottom. I'm just realizing I may have cut this off in my video, but that's C6H12O6 and 2 grams of glucose, using the periodic table to tally up how many moles of glucose are in 1 mole. Throw that in your calculator. You'll notice as we move along, grams cancel, moles of carbon dioxide cancel, moles of glucose cancel, and the only thing we have left for units is grams of glucose. So grams of glucose for our answer, 16.4, 3 sig figs in our answer because there were 3 sig figs in the question stem. So let's take a look at our mole map just to kind of think about where we went with that problem. Grams, we use the periodic table to find the moles, how many grams are in a mole. Then we used our mole ratio as that next step. Then we said moles of B on the top, so moles of B on the bottom, which was our glucose. That happened here. And then finally we were asked for grams of glucose, so we used our periodic table to end up at grams of glucose. Throw all that in your calculator, make sure you multiply across the top, divide out your bottom numbers to end up with grams of glucose for that problem. One more example for you. Example number 3. How many grams of sodium hydroxide are needed to completely react with 50 grams of sulfuric acid to form sodium sulfate? We'll assume that's aqueous, and water. Pause the video, copy that down, write out that chemical equation, and then push on pause. And here's what I got for my chemical equation. Check your work, make sure you got the right coefficients after balancing. 2, 1, 1, and 2 will balance this equation. Pause the video again. Say self, what am I given? 50 grams of sulfuric acid, and start there. Grams on the top, grams on the bottom. And there you have it. Check your answer. 40.08 grams, 3 sig figs, 3 sig figs. I want to walk through this calculation kind of like I did the last one with the mole map shown. Let me pull this back. And then give you some tips and tricks, because I find that students, when they're first starting this out, they kind of need some direction on what kind of patterns to look for when you're working out these calculations. Okay, so we started with grams. That's your grams out here. We used the periodic table to find the molar mass of 98.09. And from moles, we need to use the molar ratio. So we used a 1 mole here, but then next we used a molar ratio to cross the border from particle A to particle B. Used 1 mole once again, and the periodic table to translate to grams. And then since all of our units at this point have canceled out, cancel, 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 we just have grams of sodium hydroxide left. And so we throw this in our calculator, multiply by 2 by 40, that was our initial number, and then divide out by 98.09 because that's in the denominator. There's our answer there. So a couple of patterns to watch out for as you're finishing up these questions. Notice in each of our fractions, we're either keeping the unit the same, the particle name the same and changing the unit, or in this fraction, we kept the unit the same but changed the particle name. And in this fraction, we changed the unit but kept the particle name the same. So basic patterns here is you never want to try to change the unit and the particle name both in the same fraction. Always keep one the same and switch up the other one to work through your steps of stoichiometry as you move along. Also, just always remember to copy your particle name down. So grams on the top, grams on the bottom, those will always match in particle name as well. Moles of sulfuric acid on the top, moles of sulfuric acid on the bottom, moles of sodium hydroxide on the top, moles of sodium hydroxide on the bottom. So of course we've been doing this for a while, since chapter 10, and you're probably sick of me saying all those little steps, but I hope those little hints really help as you're working through your homework problems. So get that done. Let me know if you have questions. I have office hours again on Friday, so pop in at 1 p.m. The link is in the stream of Google Classroom for office hours at 1 p.m. Friday. Let me know, you guys. How's it going? Also, just check in with me every once in a while and make sure you're up on your handing in your assignments and stuff too. I really do miss you guys. I really wish you were here and I was able to like help you one-on-one in the classroom. But it is what it is. So hope that's helpful, and signing out.